You do not need a new vector database to improve retrieval. Add metadata filters and a quick re-rank pass. If your search returns noisy or wrong answers, you are not alone. Many systems retrieve too broadly, then hope a model will fix things. I will show a simpler path. You will learn a small, practical pipeline that cleans candidates with metadata and then lightly re-ranks the best hits. It is fast and explainable, and you can build it in plain Python. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. Think about a support bot that answers installation questions from a mixed knowledge base. The raw search finds many documents, some from chat logs, some from official docs, and some from blog posts. Success means the top result is relevant and trustworthy within a fraction of a second. The pain is noise and the cost of expensive re-rankers or large embedding indexes. Metadata plus a light re-rank gives a big quality boost with tiny compute and simple code. At its heart, this approach is two things. First, we filter by metadata to remove likely wrong sources. Second, we re-rank a very small candidate set with a cheap heuristic that favors helpful phrasing. Imagine a librarian who first narrows shelves to the right subject and then gives extra weight to books that mention the exact phrase you used. That is easy to implement and noticeably improves top 1 results. We will build a tiny demo corpus and then run 3 small boosts. You will see a raw overlap baseline, then a source filter, then a phrase boost re-rank, an intent to topic filter, and finally, a compact pipeline that uses them together. None of this needs a heavy library. The ideas map directly to larger systems later, so the code stays useful as you scale. Now we will create the minimal corpus and a naive overlap search. This snippet builds a tiny corpus and runs a naive overlap search. The variable docs holds tuples of ID, text, topic, source to keep content and metadata together. The function W tokenizes lowercase text using Python's RE to extract simple word tokens. The query queue is compared to each document by the size of the token intersection, then sorted to produce a ranked list R. Larger intersections mean higher ranks, giving us a fast baseline without any weighting. The printed ID shows the top match under raw overlap, which sets a clear starting point to improve from. Next, we will narrow candidates using metadata before scoring. This snippet narrows candidates using a metadata filter before scoring. The list comprehension sub keeps only items from the knowledge base by checking the source field in each tuple. We reuse the query Q and the tokenizer W to compute the same overlap score, but now only within the filtered set. The sorted call ranks the filtered candidates by token overlap, reducing noise from less reliable sources. Tightening the filter increases precision, but risks missing answers. Loosening it improves recall, but can add off-topic results. The printed ID shows the best match from the knowledge base slice. Now we will add a tiny re-rank that boosts documents containing a helpful phrase. This snippet lightly re-ranks top matches by boosting a helpful phrase. We create C by taking the top 3 baseline candidates using the same overlap score for efficiency. The variable P captures a domain phrase that strongly signals relevance for this query. A second sort promotes items where the phrase appears in the document text by adding 1 extra point to their base overlap score. Increasing the candidate slice beyond 3 may improve recall but costs more time. Decreasing it reduces latency while risking missed improvements. The printed ID reflects the re-ranked winner after the phrase boost. Next, we will derive a simple intent from the query and apply a topic-aware filter. This snippet derives an intent and applies a topic-aware filter. The variable want maps a query hint to a topic. choosing Setup when the token install appears. The list comprehension sub keeps documents only from the desired topic when want is set. Otherwise, it passes everything through. This simple intent to metadata step helps constrain retrieval to more likely sections for the user's task. Expanding the intent mapping increases recall but may reintroduce noise. Narrowing it boosts precision while risking misses. The printed count confirms how many candidates remain after topic filtering. Finally, we will combine filtering, retrieval, and re-rank into a compact pipeline that returns a single final result. This snippet combines filtering, retrieval, and re-rank into a tiny pipeline. Starting from the intent-filtered sublist, we rank candidates by token overlap against Q and take the top 3 for efficiency. The phrase P provides a small targeted boost that improves ordering within that short list. We select the best ID after re-ranking and emit it as the final result. Raising the candidate count can improve accuracy with more work, while reducing it speeds things up. The printed ID is the pipeline's final choice, showing a stable baseline with metadata filtering, plus a light re-rank. This toy pipeline maps directly to real systems. Replace the overlap score with a cheap embedding distance for smoother semantic matches. Use source and top-it metadata to gate results before expensive model calls. The same pattern works for FAQ search, developer docs, and internal knowledge bases. Recap in 3 points. What it is: a small pipeline that filters on metadata and then lightly re-ranks a short candidate list. When to use it: when you need better top 1 accuracy and want to avoid heavy embedding infrastructure. One caveat: overly strict filters can hide correct answers, so tune filter strictness carefully. Next step: raise the candidate slice from 3 to 5 and measure latency and top 1 accuracy. That single knob usually balances recall and cost cleanly. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.